So today we're continuing to solve systems by graphing. Well, we need to graph y equals 5. We have to go to the y-axis to number 5 because 5 is our y-intercept. Our slope is 0. That means that our line is horizontal. So y equals 5. Then we have to graph the second line. The second line says x equals y minus 6. We need to change this to slope-intercept form, which means we need to change it to y equals mx plus b, so that we can see the slope and the y-intercept. That means we need the y by itself. We can add 6 and add 6. That means x plus 6 is equal to y, or means the same thing as saying y equals x plus 6. What is our slope? Our slope is the number right in front of x. Our slope is the number right in front of x and represents our slope. So in this case, slope is invisible 1. That means our slope is 1 over 1, and our y-intercept is 6. We go to 6, 1, 2, 3, 4, 5, 6, and our slope is 1. Up 1, right 1, up 1, right 1, and we can move in the opposite direction. Down 1, left 1, down 1. Did we find the place where our lines intersect? Yes. What is the ordered pair where the lines intersect? Negative 1, 5. So this is the solution to our system, negative 1, 5. This point right here where the lines intersect. We need to solve by graphing y equals negative 2x plus 1 and y equals negative 2x minus 1. What can you see from here? What can you tell? Slopes are the same. What does it mean when the slopes are the same? It means the lines are parallel. If the lines are parallel, will they ever intersect? No. So if the solution to a system of equations is a point where they intersect or where they meet, and these are parallel lines and they're never going to meet, what is the solution? No solution. There is no solution because these lines are parallel. They have the same slope and different y-intercepts. Can we graph these either way? We can graph them just to see. So the slope here is negative 2 and the y-intercept is 1. So if I start at the y-intercept 1 with a slope of negative 2, that means down 2, right 1, down 2, right 1. In the other direction. If we graph the second line, the slope is negative 2, the y-intercept is negative 1, so we start at negative 1, down 2, right 1. Will these ever intersect? We have to solve by graphing 2x plus 4y equals 8 and y equals negative half x plus 2. What do we have to do to the first equation? We have to change to slope-intercept form, right? So I'm going to do that first. I need to subtract 2x from both sides. Divide by 4 on both sides. So y equals negative 1 over 2x plus 2. Negative 2 over 4 is simplified to negative half, and 8 divided by 4 is 2. So the two equations we're looking at now are y equals negative 2x plus 2 and y equals negative y equals negative 1 half x plus 2 and y equals negative 1 half x plus 2. What do you see about these? They're the same. So if these equations are the same, they're the same equation, where are they going to meet? Well, it's the same equation, so if we draw the line, let's graph this first, this one. And y-intercept is 2, slope is negative 1 over 2. Yes, ma'am. So I graph the first equation, y equals negative 1 over 2x plus 2, started on 2. If I had to graph this one, wouldn't I be graphing on exactly the same line? So if it's the same line, there's infinitely many solutions. That means that every ordered pair on this line is a solution to the system of equations.